welcome to another video. To prove that the product of these exponential expressions on the left hand side of this equation is equals to 1, which is on the right hand side, we'll use the fundamental laws of exponents. Okay, one of the laws of exponents we're going to use will be the one that to remove these parentheses, okay, and multiply the powers, okay, we're going to use the the statement that if we have parentheses a raised to the power of m exponent n, this will be a raised to the power of m times n. Okay, so which means so if you remove this, then we're going to have x raised to the power of q plus r over r minus p multiplied by 1 over p minus q multiplied by x raised to the power of r plus p over p minus q multiplied by 1 over q minus r multiplied by x raised to the power of p plus q over q minus r multiplied by 1 over r minus p. Okay, so this is the left hand side. So we are using the left hand side to prove the right hand side. So now I can multiply the powers. So this will be x raised to the power of 1 times q plus r. This will be q plus r. Then this will be p minus q multiplied by parentheses r minus p multiplied by x raised to the power of r plus p, because 1 times r plus p is r plus p, over p minus q multiplied by q minus r, then multiply by x raised to the power of p plus q over q minus r multiplied by r minus p. Now, since all the base are x, then we add the exponent. So which means this will be x raised to the power of q plus r over the product of p minus q and r minus p plus r plus p over p minus q multiplied by q minus r plus p plus q over q minus r, okay, multiplied by r minus p. Now, to add these fractions, okay, we need to know what the common denominator will be. That is, when we are adding fractions with different denominators, okay, then we have to look for a common denominator, okay. So now, to find the common denominator of this fraction, now we'll observe that the denominator of the fractions, okay, contain what we call cyclic terms. That is, for instance, if we have p minus q, okay, product of p minus q, q minus r, then next will be r minus p. So that's when we have a cyclic product of that, we have cyclic term. So in this case, we need p minus q, okay, multiplied by q minus r, then r minus p. So we need a common denominator of product of p minus q, q minus r, and r minus p. Okay, so what I'll do is I'm going to multiply the first fraction by q minus r divided by q minus r. The second fraction will be multiplied by r minus p divided by r minus p. Then the third fraction will be multiplied by p minus q divided by p minus q, because we need to find a common denominator of what? Of p product of p minus q, q minus r, and r minus q. So let's not forget that. Now, because I said now when the base, all the base are x, okay, and then we add the exponent. So the property I use here is the product rule for exponent. That is a property that if we have a raised to the power of n multiplied by a raised to the power of n, this will be equals to a raised to the power of m plus n. Okay, so that's the property I use in this case. All right, so like I said, to get a common denominator of the product of p minus q, q minus r, and r minus p, then I'll do it this way. I'll multiply this by q minus r, then over the product of p minus q, q minus r, and then r minus p, plus, then this will be r plus p multiplied by r minus p over p minus q, okay, multiplied by q minus r, then multiplied by r minus p, plus p plus q multiplied by p minus q over p minus q multiplied by q minus r, then r minus p. So now we have a common denominator of product of p minus q, q minus r, and r minus p. So now we can add the fractions together so that this will be x raised to the, now this can be written as a difference of two squares. That is square of q minus square of r. That's same thing as q plus r, q minus r. So this will be q squared minus r squared, plus, then this will be r squared minus p squared, plus, that one will be p squared minus q squared, okay, over the product of p minus q, q minus r, and then r minus p. So q squared minus q squared, that will be 0. R squared minus r squared, that will be 0. Negative p squared plus p squared, that will be 0 as well. So we'll be left with x raised to the 0 over the product of p minus q, q minus r, and then r minus p. And then we know that 0 divided by this product will be equals to 0. So which means that we can now have x raised to the power of 0 to be equals to 1. Since 0 divided by the product p minus q multiplied by q minus r and r minus p is equals to 0. So, and we know that any number raised to the power of 0 will be what? 1. So, and this is how to prove that the product of this exponential expression is equals to 1. The noblest pleasure. Stay tuned.